All right. So now we have a little more complicated truss than our previous problem. It's got a pin connection here and a roller, and you can see this system is set up to be kind of an overhang. Maybe it's part of a crane system, some kind of other system, and then based on that, there's a force applied here at this point B. The force is just P, so we'll solve everything as a multiple of P. Another thing to notice right as we get started, if you look at the geometry, the truss is kind of symmetric, right? These distances are the same, the height is the same, these little triangles, all the interior angles are 60, and they're all the same. So that might be some advantage later on as we look at the system. So what's our first strategy when we attack these problems? Probably want to find the reactions. So I'm going to quickly redraw the structure over here. I'm not going to worry about the internal configuration. Just going to kind of draw an outside envelope of the system. And then I'm going to show that I have a force P, and then at this rocker right in the middle, I'll assume I have a reaction. I'll call that EY. And then over here at A, it's a pin, so I'll have AY and AX. And I'll just go ahead and write these in, that this is 4 meters and 4 meters. So my point now would be just to find these reaction forces. We should be able to do that. There's 3 of them. I can write 3 equations. So let's start. I'm going to sum moments about some point. What's a good point to sum moments about? Yeah, A is a good one because it's a pin. You could also do it at E and get some results, but I'll go with A. Stick to my strategy of always trying to first sum moments at the pin. So there's my statement. Let's see what I've got. So about A, I've got EY creating moment and P creating moment. EY is going to create what kind of moment about A with right-hand rule? Positive. So the moment will be EY times the distance between A and E, which is 4. And then I've got this load P. What kind of moment is it going to create about A? Positive or negative? Negative. And the moment is going to be the force P times the distance from A to P, which looks like 8 meters. Well, that's a pretty easy one to solve. It looks like EY is going to be 2P, right? Not bad. All right, now I can find my other reaction. I will sum forces in the Y direction. So there's my equilibrium statement. So in the Y direction I have what? I have AY and EY. They're both up. So for me that's positive. AY plus EY. What else is vertical? P. And it's down, so that's going to be negative. So I can plug my EY right into there. I should be able to solve for AY. And it looks like the answer is minus P. Interesting enough, that's the same kind of ratio we had on the previous problem. I don't know, it just worked out that way. That's not a pattern that you should see every time. And then last, we can sum forces in the X direction. Make sure they're 0. And in this case, all we have is AX. So AX is 0. We've got our reactions. So now let's explore a strategy of how we work our way through this system. All right, we have 1, 2, 3, 4, 5 different joint points to go. 2 equations at each one. Should we start at B? B's a terrible place. Why? 1, 2, 3 bar forces. What about C? Another terrible place. What about A? A's good. Only have 1, 2 unknowns. What about E? That's the worst place to start, right? There's 4 unknowns there. What about D? D might be the best place to start. Why? Well, it's very similar to A, but I don't have any reactions to deal with out here. I just have P. So if I had made a mistake and have wrong answers at A, it won't affect my solution out here. So with that kind of a strategy, I'm going to start at D. Could you start at A and be successful? Of course. So there's my joint, and I have, of course, the load P acting down. And now I'm going to assume tension in force DE and tension in force CD. And I also know what? That the internal angle here is 60. Now, DE only has an x component. CD has x and y. So both of them have x components, so we probably won't start with the x equation. We'll start with the y equation. So, summing forces in the y direction, assuming up is positive. There's our equilibrium statement. Let's do that. So, in the x direction, I have the vertical component of CD, and the vertical component is going to be what? The sine of 60, right? So I've got, and it's acting up, so I've got force CD sine 60 acting up, and then what do I have acting down? Minus P. So what is the force CD? It looks like it's going to be positive.
P over sine 60.
What is it going to be?
P over sine 60.
Yeah, what is that? Numerically. Should be 1 point something. What's 1 divided by the sine of 60? 1.155 P. That sound reasonable? Looks like it's in tension, right? Does that make sense? Did I do that right? Yeah. So what does that mean? So if I pull this system down, this whole top chord is going to try to what? Stretch. The way it's supported here, right? So I imagine all these outer chord members will go into tension. I imagine all these bottom chords will try to compress. So CD being in tension is not an unusual result. I think that's reasonable. So now I can sum forces in the x direction. And I should be able to solve for DE. So what do I have? Well, looking at my components, both of the components in the x direction are to the left, so they're going to be negative. So I'm going to get negative FDE minus CD cosine 60. So I should be able to solve for the force in DE. It looks like it's going to be negative. So what's that going to be? So I'm going to take my 1.55 P and plug it in here. So multiply this times the cosine of 60, and what do you get? 0.578. Everybody else get that? So 0.578 P. Okay, we're out of time for today, so I'll pick up here, way into the future on Tuesday. But what would be the next best place to go? I've got these two. Could I go to C now? I could. Could I go to E? No, still no. And I still can't go to B. Could I go to A? Yes, I can. In fact, if you look at A and you draw it, it's going to look just like this except rotated. So you probably get similar results for the diagonal and the horizontal member at A. So that's what I'll do next. And then let's say I have those forces at A and B. Then where should I go? Could I go to E? could, but both my elements have x and y components. So that'd be 2 equations, 2 unknowns. But I could go to B and C because I would know this one, and one of the unknowns is just in the x direction. So probably my strategy would be next to go to A, and then either B or C, and then the other one, C or B, and then I'll be done. So we'll finish that up on Tuesday. All right. Have a good weekend. See you guys then.